Okay, hello. That's my first slide done for me, which is excellent. So, hello all, I am Theo, and I've been introduced. So, my talk today, You Do You, is part hoping to show you some useful tools or communities that might benefit you in your research, but it's also a call to action in some ways. So, we'll get there. So many of you might have seen a sentence or a sort of statement such as this. 80% of data science is, and this is where I'd like some audience participation, but it's not going to work very well in the current situation. But hopefully many of you have seen or said a statement similar to this. 80% of data science, 80% of machine learning, 90% of XYZ is. Answers range from data managing, data wrangling, cleaning, formatting, validating, all these sorts of activities are recognized as an important part of what happens in any aspect of data science. So here you go, here's my lovely diagram of data science. That's simplified it all for you, I'm sure. And the thing that is good about this very common statement, I guess, is that it acknowledges these activities as data science activities. However, it's often sort of slightly disdainfully, isn't it? It's kind of like a chore or something, you know, something you found on the bottom of your shoe that you're not too excited about the fact, even if it is true. But from an efficiency point of view, if you can make one part of this diagram 50% more efficient, which is going to benefit you more? You know, 50% of 80% or 50% of 20%? On a similar vein, now there's lots of exciting new developments, architectures, approaches that we've seen discussed today and over the last few days, and more generally in the sort of data sciences and environmental sciences. These are just three random ones I've picked, and in the mandatory Venn diagram, I've sort of I'm trying to show that there's a lot of overlap here, and this is the stuff we just talked about. There's a lot of need to process data, clean data, find data, format data, all these activities, you know, pipelines, compute infrastructure, running multiple experiments to do hyperparameter tuning. These things are common no matter where you're going with your data science research, your machine learning research. You know, there's a big area of overlap. So again, work here in this overlap benefits a large community of people. And this is data engineering. This is what I do. This is my day job, just trying to research this area and push forward this area. And my takeaway and my argument today is that better data engineering is the most effective accelerant of data science as a whole. If we can make that 80% more effective, if we can make that large, broad area of overlap more effective, data science will be more effective. So that's my takeaway point. If you've come with me this far and you agree with me this far, great. The next few slides are some particular examples of some projects that might be useful and you might want to be aware of. But you know, this is the key that I'm trying to convince people of. Okay, so the first community technology I want to present is STAC, which stands for Spatiotemporal Asset Catalogs. And the idea here is a common language to describe data sets that have some extent in space and some extent in time, which covers pretty much all weather and climate data sets. And the aim is, you know, allowing these data sets to be more easily discovered, better indexed, easier to interact with, so that new code doesn't need to be written when there's a new API or a new data set that comes out. And And it seeks to remove the burden of building unique pipelines. So something I imagine a lot of you have had to do is build some sort of pipeline to get your data to a certain state ready to go. And the idea here is to really spur on common tooling. So here is a not terribly exciting video of a stack. And what's important, stack is the underneath, what's the word, set of standards rather than the particular interface you're seeing. That's one way of visualizing stack, I suppose, is this web tool. But there's loads more ways of interacting with stack. But the idea is there was catalogs from Amazon, from Google on here. So, you know, cross-cloud providers, you can search, drill into, and, you know, use various different tools to interact with stack. So, you know, I might challenge you to think about whether the data that you are publishing could be shared via stack, whether the tools you are developing could interact with stack, for example. So, moving on slightly, here's a little story. I had some data I wanted to analyze. It was a moderately sized data set, about a terabyte or so, consisting of, you know, a few hundred files. I want to do a rolling mean. Okay, fairly simple task. So, you know, I fire up my notebook and start loading in the data. Have a look at them. Okay, hundreds of files, probably too much to load into memory all at once. Let's have a look at a few of them, understand what's going on here. So let's batch it by time. I'm doing some sort of rolling average. Let's batch it by time. Then I've got to worry about finding the file names based on dates, and there's certain peculiarities with some months have this many dates and some have that many, et cetera, et cetera. So there's some logic to deal with that. You know, okay, great. I'm going to calculate the rolling mean now based on a set of files, calculate the rolling mean and aggregate all the different rolling means from the different files. I'm going to, I hit a problem where I can't access the same file at the same time in parallel because there's a pointer clash or something, some sort of issue goes on there. So let's code around that. Then let's process it on a cluster because it's taking a long time. If I just try to do it on one core, so let's try to do that across a cluster, and you know. And finally, yes, we have our results. We've got some interesting analysis we have completed. This might be a sort of familiar process that you have gone through yourself. So the alternative story, if all goes well, looks like this. I have some data I want to load. It's exactly the same data. This time it's stored in what we call a analysis-ready format, or analysis-ready cloud optimized, ARCO. And in this scenario, I load the data and I plot the data. And you know, if all goes well, it really is as simple as that. And it massively improves my performance as a developer or someone doing it as a data researcher, and reduces errors. So analysis-ready data is an idea, it's a concept as opposed to a specific technology. But it's about data that is trivial to load and analyze. You know, you can start asking those questions, you can start querying, you can start interacting with the metadata instantly. Cloud optimized is taking that to the recognition of the importance of public cloud in today's compute environment. Public cloud is a great way of being able to share and interact and work across organizations, but data has to be stored in a certain way to be optimal often. And something that I personally observed in the weather and climate community is that we often do a very good job of describing individual files. So you have a beautifully described netcdf file, and then you happily hand over 6 million of them. And there is no kind of framework or no clear way of how those 6 million jigsaw pieces fit together and interact with each other and how you handle all of them at once. And this is, you know, ARCO is about applying to a whole data set, a conceptual idea, like every single model run of the Met Office's high resolution UK model for the last 2 years. You know, that's a conceptual data set, rather than worrying about one individual file here and this individual file there and there. And the other power is it makes the data provider, or the idea is the data provider does most of the cleaning, amalgamating, indexing, they have to understand the data. They are the people who understand the data, and they do that hard work so that people who want to do the data science don't have to, as far as possible. It makes it less error prone. If you think about that code that I wrote the first time around, all those lines of code, there's going to be mistakes in there compared to the second sort of set of code. So, when you are working on data, when you're publicizing data, when you're sharing data, think about making it analysis ready. There are some example formats like Zart and TileDB, and there are others you should consider. So the last project that I wanted to talk about is Pangaea. And Pangaea is a community, first and foremost, that is concerned with the problems of big data geoscience. It creates open source software and open source infrastructure to solve those problems. It has specific groups working on machine learning, for example. Here's some links. But for predominantly, it is a community, and there are people out there with similar problems to yours, or so the solutions you find to them are useful to others, and people may already have the solutions you are interested in. And I'm really keen to promote this earth science community. As I say, it's a community first and foremost, but a community that produces tools. This video is a brief demonstration of what those tools can look like, although they come in many different shapes and sizes. So I hope this video is coming through okay. So it tends to be an interaction via a Jupyter Notebook-like experience. This is a Jupyter Labs, for example. If you're not familiar with that, I'm happy to take questions on that. Interactivity is a big theme in Pangaea. And then another big theme is about cluster and cluster compute and the need to do big scale compute. And so with this deceptively simple couple of lines of code there, this user has actually started up a cluster which will elastically scale between 2 and 100 compute nodes, depending on the complexity of the problem. And it will work out how complex the problem is, how quickly it's getting solved, and scale up and acquire more workers to solve it. What I love and what some of these charts starting to show up now are showing is what's going on behind the scenes. This is a beautifully complex challenge in data engineering terms. Like, you've got 100 machines, you're coordinating them. Some of them will drop out and lose bits of memory. And how do you make sure that you get that memory back or recompute that part of the task? Are you doing that in parallel? And which bits can you do in parallel and which bits you can't? All that's going on. But the user here isn't thinking about that. They're saying, calculate a rolling mean or subtract this thing from that thing. So yeah, that's where Pangaea is really excelling. And we can skip forward a little bit, and the punchline is, essentially you get the plot out you're interested in at the end here somewhere, or whatever analysis you want to do. There we go. So here's our plot. So come on. Apologies, my slides aren't progressing as well as I wanted. There we go. So you'll be pleased to know I'm going to buy you back some time. So if you get any questions for me, that'd be great. I'm going to move on to the conclusions. Like I said, those 3 kind of projects are just scratching the surface of the sort of activities that are going on in the data engineering space. And so I'm saying, give some love to that data wrangling. Don't see it purely as a chore. It's also an opportunity to really improve data science for everyone. So please, it will take time, it will take effort on your part, but embrace and engage with these wider data engineering efforts. They might be inside your team, might be inside your institution, and it's certainly much wider across the globe. Think about how you could use some of these open source tools. Could you format your data in a way and share it in a way that's analysis ready, etc. And as I say, my takeaway is that I think focusing on data engineering, really putting love, effort, and time into it will accelerate data science faster than anything else, essentially. So thank you very much for your time today. There's some links to this presentation up there, and from there you can find the links to other bits and bobs, my contact details, etc. Happy to take questions now, happy to take questions offline at another time. But thank you very much for the opportunity to talk today. It's been great.